In the previous section, we notified the host VI of one-time or infrequent events from the FPGA VI using interrupts. By the end of this module, you will be able to implement an FPGA watchdog. In this section, we'll talk about how to implement an FPGA watchdog. So what's the purpose of a watchdog? So in this case, we're going to have an FPGA VI, and then within the FPGA VI, you'll be able to monitor the status of the host VI. So for example, if the host becomes unresponsive, maybe because the CPU usage went way too high or something like that, because we're monitoring it from the FPGA VI, we can actually take action inside the FPGA VI. So for example, the FPGA VI, if the host becomes unresponsive, it can reboot the host computer, or maybe it can just set all the I/O to safe states. So let's take a look at LabVIEW and see how it can be implemented. So if we look at the top, we have our host VI. Okay, so imagine this is one of the loops that's running on your host VI, and notice we have a watchdog pet rate over there, and that's going to be how often the watchdog loop runs. Okay, so we expect that the watchdog loop, if everything is going okay on our host VI and the host VI is responsive, to be petting the watchdog at a specified rate. So notice that in the watchdog loop, you have a read-write control function, and we're setting the pet watchdog to true. Okay, now let's jump down to the FPGA VI. So in the FPGA VI at the bottom, let's take a look at the loop. Notice that the pet watchdog control is sitting there, and notice that the control is also set to a mechanical action of latch when released. Okay, so that means every time the host is setting that to true, it'll read that true once in the FPGA VI and set it right back to false. Okay, so in the FPGA VI, we also are looking at another control, which with the watchdog timeout period in ticks. Okay, so what this is doing is it's setting the FPGA VI to figure out a timeout period of when it doesn't receive a pet watchdog from the host. Okay, so if we take a look at our sub VI in there, the FPGA watchdog elapsed time, what that's doing is it's taking a look at the current tick count. So that blue function right there is a tick count VI. It's taking a look at it and it's seeing, okay, has the pet watchdog control been set to true? And what it's doing is it's continuously checking this. And for the FPGA VI to know that the host is actually responsive, then we're going to be able to receive a true on the pet watchdog control before the watchdog timeout period elapses. So if the host is responsive, we're going to keep getting that pet watchdog to be true at a nice periodic rate. However, if the host VI becomes unresponsive for some reason, and then that watchdog loop in the host VI at the top doesn't get a chance to run, so let's say the watchdog timeout period is something like 10 seconds. Okay, well, if the host VI gets locked up and the watchdog loop does not execute for 10 seconds, that means nothing is setting the pet watchdog to true. So if that happens, let's look at the FPGA VI and see how it handles it. Well, then the FPGA watchdog elapsed time is going to notice that, okay, we've timed out, 10 seconds have passed, and the host has not set pet watchdog to true. In that case, we're going to go to the case structure there and execute the true case. So in the true case, we know that if it's executed, then the timeout has expired, and now we can take action accordingly. Okay, so for example, we can set the system reset to true, and we can reboot our host. Or we can also, at the same time, set the watchdog timed out indicator to true, and maybe what that does is it sets up the FPGA VI in another section to set all the I/O to a safe state. So we see here in LabVIEW we can implement something where we're able to monitor the responsiveness of the host from the FPGA VI. So in the last slide, we saw an example of implementing an FPGA watchdog. If you want a more full-featured example, you can go to the FPGA control sample project in LabVIEW FPGA 2012. So I highly recommend going there. Now that we've gotten to the end of this course, it would be great to explore this on your own. And let me go ahead and open LabVIEW and show you how you can look at the sample project. To find the FPGA sample project that's included in LabVIEW 2012, you're going to have to go to Create Project. So I'm going to click that. And then notice you can go to Sample Projects here, and I'm going to go to Compact Rio. And then notice within Compact Rio, we have a sample project where we're using LabVIEW FPGA to implement control on the Compact Rio. So this is going to be a full-featured example where we have a full-featured FPGA VI. We're going to have an RT VI with that as well. And this is a great one to look at, and you can kind of look at all the principles that we've learned in the LabVIEW FPGA course and see how they're implemented for a real application. And this one's going to do a lot of PID control with multiple channels. So there's a lot of stuff going on, and this would be a great way to just see how these principles are actually used in a real-world application. So to continue your LabVIEW education, at this point, if you are using a real-time target, such as cRio or a PXI that's running a real-time operating system, then I definitely recommend looking at the LabVIEW Real-Time 1 course and also the LabVIEW Real-Time 2 course to learn more about RT programming. And then for LabVIEW, if you want to increase your skills in LabVIEW in general, and also especially on the Windows side, you want to take LabVIEW Core 2 and LabVIEW Core 3, and this will help you to create scalable, readable, and maintainable VIs, whether you're programming for FPGAs or Windows. A lot of those concepts will span across both. And then you can do some other classes as well. There's LabVIEW Performance if you're looking into how to increase performance on VIs and things like that.